everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. The subject for this video lecture is probability and statistics. The subtopic what we are going to discuss is problems on probability distributions. In detail, we will discuss about definitions of binomial, Poisson, and normal distributions. Based on that, there is problems based on binomial, Poisson, and normal distributions we are going to discuss. Definition of binomial distribution. That is, a random variable, capital X, has a binomial distribution if it assumes only non-negative values and its probability density function, which is given by capital P of X equal to R, P of R equal to NCR, P power R, Q power N minus R. Now, this R, which is taking the value from 0 to n, that is finite. The P represents probability of success, Q represents probability of failure, and Q equal to 1 minus P, which is written. How we have taken Q equal to 1 minus P based on P plus Q equal to 1, from which we obtained Q equal to 1 minus P. Here the notations, the explanations are given. P, it's nothing but probability of success. Q, probability of failures. N, number of trials. So we can see here, we have to be very careful about the formula, that is NCR P power R Q power N minus R, where R is taking the value from 0 to N, and probability of success plus probability of failure, that is total probability is 1, from which we obtained Q equal to 1 minus P. This is the notation, because the previous slide, what we have seen it, that is instead of X, the previous slide we used the notation R, but we are going to use the complete this video lecture, this notation X. That is, here the B represents binomial distribution. Totally ours is probability distribution. 3 distributions we are going to discuss. The first one is binomial. So the binomial distribution, the formula is NCX, P power X, Q power N minus X. That's what this is. Where our N represents number of trials. If die is there, number of how many times we are throwing. Suppose any industry, how many products total produced. So N represents that. P represents in the problem what is the condition which is given. Satisfying the condition, what is the output which is coming. That is P. That is probability of success. That opposite one, probability of failure. Then what about X? X is the specific target, that is taking the value from 0 to n. So Q equal to 1 minus P. Throughout the binomial distribution, this is the formula we are going to use. So we can see it, the star mark which indicates, so the binomial distribution, that is a formula. And what about X and Q? So the first problem we are going to discuss, 6 dice are thrown 729 times. How many times do you expect at least 3 dice to show a 5 or 6. So first thing, we have to read the question carefully. How many dice are given? Suppose in this particular problem dice is there, or some problem maybe coins also will be there. How many they are given? Here the dice, 6 dice are given. The 6 dice, how many times we are throwing? 729 times we are throwing. Okay, fine. So this is the conditions which are given in the problem. What we have to do? What is the expectation? What is the output we have to produce? That is at least 3 dice. We are throwing 6 dice. Totally we have 6 dice. That too at a time we are throwing. We are not giving a gap. That is one die throwing, some gap giving, the space, time space giving another. No. Every dice at a time we are throwing. Now the question is at least 3 dice. Among the 6 dice what we are throwing, in that 3 dice, the possibility of getting 5 or 6. At least. So compulsory we should have 3 dice. More also we can have. 4 also we can have. 5 also we can have. 6 also we can have. But it's not possible to have 7. Because we have only 6 dice. So now what is the conditions? What are the data which are given in the question? We can see. So the P, the probability of success. What is the condition which is given satisfying the output we will be taking as probability of success? Now 5 it is there. To get the 5, so we are throwing 5. The number 5, if it comes, the single die, 5 comes, we know it, the probability, the basic definition of probability. That is, what is the condition? Satisfying, favoring that condition. Now 5 is there. Favoring that condition, what is the output? 1 divided by total output for the single die. That is 6. The same for the 6 if we get also, we will be getting 1 by 6. So ours is 5 or 6. So 1 by 6 plus 1 by 6, 2 by 6, which is equal to 1 by 3. So we obtained P, probability of success, 1 by 3. Here, this is the presentation we are expecting the students to produce. Here the problems to problem, this differs. What is the target condition which is given? Occurrence of 5 or 6 in one throw. This is problem to problem differs. Q. If we obtain P, it is very easy for us to get what is Q. Because 1 minus P is the formula. We substituted in the P place 1 by 3, we obtained 2 by 3. So at least a word which is there, this is mathematically greater than or equal to, at least, at most, equal. These are all mathematical notations, we must know it. At least, that is dominating in our problem, the mathematically greater than or equal to. So we can see this very clearly. This is highlighted. Our problem focusing on occurrence of 5 or 6 in one throw. So we have totally 6 dice. The first question is the probability of getting at least 3 dice. Totally we have 6, but at least 3 dice which are showing 5 or 6. At least mathematically greater than or equal to 3. We can see it here. This part mathematically we have written here. So totally 6 we have it. So 3 is included because of this equal sign. 3. Next 4, 5, 6. We can't write 7 because up to 6 dies only in this problem, the condition which is given. Now, the binomial distribution formula is ncx p power x q power n minus x. The notations x, the specific target. That is here the specific target is when x equal to 3. And the binomial distribution, x is playing 3 places. And n is 2 places, p 1 place, q 1 place. That is also, we have to observe the formula, these variables, how many times they are playing a role. These are all which will make us to commit errors, free error. We won't commit any errors. So x place, here according to here this 3, we will substitute in 3 places. We can see it here. Yeah, this is for x equal to 3. 1, 2, 3 places x is there in the formula. 1, 2, 3. So we substituted. This is p, this is q. Here the role of n is substituted. So we completed when x equal to 3. In the similar manner, we have to when x equal to 4. So 1, 2, 3. 3 places x place we substituted 4. This 1 by 3 for p and 2 by 3 for q, whereas our n is 6. The similar manner we can do it, the treatment which will be given for x equal to 5 and x equal to 6. So the totally we are finding all the 4 terms, 1 by 3 power 6 is common. The leftover, the terms using the calculator we can find out easily. So the first one 160, second one 60, 12 and the last one the value is 1. We got it 233 divided by 729. This is for throwing one time. But our problem, the 6 dice are thrown 729 times. So that's what. So this is for one time. If it is 729 times, this is multiplied by 729, which is equal to 233. So the second problem is the incidence of an occupational disease in an industry is such that the workers have a 20% chance of suffering from it. What is the probability that out of 6 workers chosen at random, 4 or more will suffer from the disease? 2-3 times we can read the question. Nothing wrong in it. Now, in the industry, the workers are there, they are working. Some diseases they are suffering. How much percentage of the workers are suffering? 20% of the workers are suffering. So this is the condition that satisfying the output, which is going to, what we are going to get is P. Fine. Randomly we are picking some workers. How many workers we are picking? We are selecting some 6 workers randomly. We are not specifically, we are not. Randomly we are selecting 6 workers. Fine. In that, what we are finding, 4 or more suffering from that particular disease. Okay. Now P. So here it is there. In the total industry, 20% are affected by that particular disease. Yes, workers suffering from disease. This is the condition only given in this particular problem. 20% are affected. So we can see it, particularly this we have to focus it. Satisfying 20% in decimal we converted 0.2. So the P, the probability of success is 0.2. Q, if you obtained P, it is very easy for us to calculate what is Q. So 1 minus P, which is equal to 1 minus 0.2, is 0.8. N, randomly we are picking 6 workers. Then what is the question we are expected to do it? The probability that 4 or more workers will suffer from disease. That is probability of, we want this, 4 or more workers will suffer from disease. Mathematically we can write greater than or equal to 4. And our probability, that is binomial distribution formula, is NCX P power X Q power N minus X. 4 is included because of this equal sign. 4, so we can see it because X is taking the value from 0 to N according to binomial distribution formula, 0 to N. Ours is 6 workers randomly we are selecting. So 0, 1, 2, 3, 4, 5, 6. 4 is included. Greater than 4, 5, 6. This is the data we needed, we required, satisfying this condition. So now we are applying when x equal to 4 in the binomial distribution formula to avoid the confusions, to avoid the careless mistakes. 1, 2, 3. X is dominating 3 places. We replaced it correctly. The X value 4. P is 0.2. Q is 0.8. Our N is 6 because we selected randomly 6 workers. Now, similar way we will do it, X equal to 5. Remaining everything is same comparing to the previous step. So now 1, 2, 3. So the 3 places X is replaced. Now when X equal to 6 also, same way we replaced, that is when X equal to 4, when X equal to 5 and X equal to 6. Throughout we are finding 0.2, the whole power 4 is common. We have taken out, and 6C4, the value which is written, and 0.8, the whole square is written. Similar way here, 6C5, the value 6. Here 0.2, the whole power 4 we have taken out, the balance is 0.2. Here 0.8, the whole power 1. Here 6C6, the value is 1. Here the balance is 0.2, the whole square, because the 4 we have taken out. Here 0.8, the whole power 0, the value is 1. So the simplifications what we have done it is 0.2, the whole power 4. The first term 9.6, the second one 0.96, and the third one is 0.04. Approximately we obtained the result 0.017. So we can see it first very carefully. The star indicates x is greater than or equal to 4. The condition to be 4, 5, 6. So we discussed binomial distribution. Now we will move to Poisson distribution. A random variable, capital X, is said to follow a Poisson distribution if it assumes only non-negative values and its probability density function is given by p of x equal to x, p of x equal to e power minus lambda, lambda power x by x factorial, where x is taking the value from 0, 1, 2, 3, so on. What is the difference between binomial and Poisson? There, x is taking the value from 0 to n we have written. In the binomial distribution, Poisson, x is 0 to infinity. Binomial distribution, the formula which is derived by the mathematician Denis Poisson, and he has taken the mean of the binomial distribution as lambda. He derived this formula and his name only it is kept, and it has become Poisson formula, e power minus lambda into lambda power x by x factorial, where x is taking the value from 0 to infinity. Lambda is a positive number, the parameter, which is the parameter of this Poisson distribution. So based on now the Poisson distribution, we will concentrate the problems. A manufacturer knows that the condensers he makes contain an average 1% defective. He packs them in boxes of 100. What is the probability that a box picked at random will contain 3 or more faulty condensers? First of all, now binomial we discussed it. Now Poisson we are discussing. First, how to identify this problem comes under binomial or Poisson. That is the first question. It is in front of us. We have to face that. Very easy thing here, the word average, because just now I told that is the mathematician Denis Poisson, mean of the binomial distribution, mean, it's nothing but average. Based on that, he derived the Poisson formula. So the average mean which is given, and we will move to Poisson distribution. So 1%, whatever he is manufacturing, that 1% it is defective. This is the target which is given in the question, that we have to accept it. Each box they are packing 100 condensers. Then what they are expecting has to do it. What is the probability that a box picked at random will contain 3 or more faulty condensers? Totally, that industry, what they are manufacturing, average 1% is defective. Each box 100 they are packing. And the probability of what we want, what is our required data, what is the output we have to find is 3 or more faulty condensers. Yeah, P, the probability of defective condensers. That is the total what we are manufacturing, 1% is defective. So 1 by 100, which is 0.01. N equal to total number of condensers, that is each box we are putting 100. Lambda mean equal to NP. So now 100, that is N, P. P is nothing but the probability of success. Here is our defective condensers, that is a condition we have to accept it, that the output is playing the role of P. So 100 into 0.01 equal to 1. Why these calculations we have to do it? Because the Poisson formula is e power minus lambda into lambda power x by x factorial. The lambda is playing a role, but in the problem the lambda value which is not given. So we have to find the lambda. The lambda is nothing but np. So we obtained now lambda equal to 1. So the Poisson distribution formula is P of x equal to x e power minus lambda into lambda power x by x factorial. We have to be very careful. The star which indicates the Poisson formula, lambda is the mean, x is the specific target. So the question actually each box 100 condensers we are keeping, we are packing. 3 or more faulty condensers. 3 or more. So mathematically greater than or equal to 3. So greater than or equal to 3. So 0, 1, 2, 3, so on up to 100 it is there. 100 condensers in the box it is there. What we are asking, what we have to do it, greater than or equal to 3. Yeah, 3 is included. Greater than 3, 3 to 100. Nearly how many times we have to do it? For 3 one-time Poisson, 4, 5, 6. Number of times we have to do it for our required data. It's a very lengthy method. Instead, very smart way we can do it. We know it, the total probability is 1. So the total probability is 1 in which the unwanted data we can subtract it. Yeah, that's what we have done it. If it's a lengthy method, escaping, we have done it a very smart way to consume the time. So 1 minus P of x equal to 0, 1 and 2. So 1 minus which is written as it is. Now we know the Poisson formula. E power minus lambda, lambda power x by x factorial. First x is taking the value 0. That's what it is written. Next x is taking the value 1 and x is taking the value 2. Here actually immediately the question will be coming. When we are substituting x value, the lambda value also we know it. Just now we derived the lambda value as the previous slide. Yeah, the lambda value is 1. Yeah, to save the time purpose, we didn't substitute. You can see it now. 1 minus, this value is 1, 0 factorial is 1. So this term which has become like this. So we are finding e power minus lambda, which is common. That we have taken out. Lambda is 1. That we substituted. Otherwise, if we want in this step only lambda value substituting also, it is correct. Simplifications, obeying mathematical laws, any way we can do it. So now 1 minus e power minus 1, this complete, the addition is 5 by 2. So we obtained using the calculator, we can calculate it. The value is 0.9197, which is subtracted from 1. The final result we obtained 0.0803. So now we can focus. That is the box 3 are more or faulty. So that is the reason x equal to 0, x equal to 1, x equal to 2, and here also in the formula x equal to 2, we replaced it. And finally, we obtained the result 0.0803. The next problem is a distributor of beam seeds determines from extensive tests that 5% of large batch of seeds will not germinate. So the seeds are there. In the seeds, 5% they are unfit for the germination. He sells the seeds in packets of 200. Each packet 200 seeds are there. And he is giving the guarantee that 90% compulsory germination will take place. Then what we have to do is determine the probability that a particular packet will violate the guarantee. That means it won't germinate. First, we have to pick up what is the target. Yes, the total seeds 5% will not germinate. That we have to accept it. Yes. So that is our P. Probability of success. What is given the problem condition satisfying the data which is coming out is P. Probability of success. 5% seeds it won't germinate. 5 by 100. It is nothing but 0.05. N. Each packet 200. It's not actually seeds, that is. So number of seeds is 200. Now mean. So N is 200, P is 0.05. We got it. Lambda is 10. So Poisson distribution formula is x equal to x e power minus lambda into lambda power x by x factorial. Lambda we obtained, that is 10, but x, that we have to see it. What they are asking us? They are asking the percentage. Each packet 200 seeds are there. 90% of the seeds will germinate. 10% it won't germinate. That probability only we expected to solve. So 200, the 90% it's 180. So 180 seeds are under germination condition. Only 10%, that means 20 seeds are not under the condition of germination. So we can let x be the number of seeds that do not germinate. Then P of x equal to x e power minus lambda, lambda power x by x factorial. What we obtained, that is in the place of lambda, we replace it by 10. A packet will violate guarantee if it contains more than 20 germination seeds. This 20, how we obtained it? The total is 200 seeds, 90%, that is 180 for the germination. Violate, doesn't support, that is 10%, that is 200 minus 180, 20, doesn't support for germination seeds. Yeah, that is what here written 20. So now you can see it here, the star which represents. Now the 20. Why we have taken 20? Because of here we can see more than 20. That is the reason we selected. But more than 20, 21, 22, up to 200. How many times we have to apply Poisson? It takes more time. Very lengthy procedure. Smart way. The total probability is 1. We can subtract the unwanted data. So that's what we have done it here. 1 minus P of x less than or equal to 20. So x equal to 0, 1, 2, up to 20. So it is very easy for x equal to 0 one time, for the x equal to 1, x equal to 2, up to 20 we can apply Poisson formula. We applied it. So the similar way the method, here x place 0, here x place 1, here 2 is taking, the last one is x is taking the value 20. The first one, only here the changes are there, remaining and all as it is written. Because lambda power 0, the value is 1. 0 factorial, the value is also 1. This step, we are finding e power minus lambda, which is common. We have taken outside, the balance which is put inside. Lambda value, the last stage we are applying the lambda value to save the time. If it is, that's what I told already, in the initial stage also we can apply, nothing wrong in it. So using the calculator, this everything the calculation is 0.9984, which is subtracted from 1, we obtained the result 0.0016. Yeah, now we can see we completed binomial and Poisson. The third distribution is normal. 1,000 students have written an examination. The mean of the test is 35, standard deviation is 5. Assuming the distribution to be normal, find how many students marks lie between 25 and 40, how many students get more than 40, how many students get below 20, and how many students get more than 50. First, the normal distribution, two types. When mean and standard deviation both are given, if they are not given. Two types. The first type, we will do it now. Yes, what is the data which is given? Here, the mean. The symbol of mean, mu. The data is 35. Standard deviation, sigma. The value is 5. The first question is, x lies between 25 and 40. So we have written x lies between 25 and 40, and we are naming 25 as x1, 40 as x2. So we named it. Now x1 equal to 25. The normal distribution, we can't plot this 25 as it is. They should be converted into z points. So which scale is going to help us? This is the scale, that is x1 to be converted as z1. The formula is x1 minus mu by sigma. So we are substituting the respective values in the particular places. So 25 minus mu value is 35 and sigma is 5. We obtained after simplification minus 2. So the 25, the job is over. Next we will move to 40. The 40, we named it as x2 and it should be converted into z2. So the formula x2 minus mu by sigma. So z2 equal to 40 minus 35 by 5. The result is 1. So we can see so now the 25, x1 converted, we applied formula, we obtained the result. 40, x2, z2, we obtained the result 1. That's what the star indicates. Yes, now we will solve using this normal curve. It is a bell-shaped curve and the middle, the line, symmetrically, it's a symmetrical line. It divides the area of the portion equally. Now our question is, x lies between 25 and 40. So the 25, x1, x1 to z1. 40, the name is x2. It is converted into z2. Now, we have to say it, z1, the value is minus 2. If it is, the value what we obtained is negative. So, left side, that is the middle one, z equal to 0, minus 2, the negative should be left to this point we have to fix. So it is fixed left to z equal to 0, whereas z2 is the positive value. It should be right to z equal to 0. It should be placed. So we placed it correctly, and so that's what here the bell shaped, and so we can see it minus 2 z1 and vertically positive, and it is placed on the right side. So we will move to the solving the final stage of this particular part, that is z1, which is replaced by minus 2, z2, which is replaced by 1. This is the final, before the two diagrams which are given, that is the stages of to get this fair diagram. Z equal to 0, 1 and minus 2 and 1. Now we wanted this shaded part. Here is there our minus 2, here is there, that is z1 and z2, that the area is nothing but which is shaded here. So compulsory when we are finding, here is there 0 to this part we can calculate, and 0 to this part easily we can calculate. Both to be added, that's what which is written here, area of z1 plus area of z2. z1 it's nothing but minus 2, area of z2 is 1, and we obtained the value. This value how we obtained 0.4772. For its area of 1 is 0.3413. That is with the help of the table, normal distribution table. So 0.8185. But so this is the point what we obtained the value 0.8185 between 25 and 40. But totally 1000 students are there. So with the value what we obtained, it should be multiplied by 1000. So we can tell approximately 819 students are below, that is between 25 and 40. We can see now this point, this how we obtained this 0.4772, and this area of 1 is 0.3413. With the help of this normal table, we obtained it. So now, first one is minus 2. Here we can see it, the 2 is there. This is the value we obtained it. Here in the area, there is no negative, positive. Only the minus sign to represent a normal curve. If it is negative, left ordinate we will be moving. The next point is 1. That is, here we can see it. This is the value we have that is pointed there in the particular places. Yeah, we can see it here. That's what we calculated. This is the way we can see the normal distribution table, and we can do it. So the particularly which area we are focusing, how we obtained, the star indicates this is the area that calculating we obtained 819 students are between 25 and 40. So the next question is x is greater than 40. The similar way, The 40 we are naming as x1. x1 to be converted into z1 with the help of this scale x1 minus mu by sigma. So x1 is 40, mu and sigma, the values are given as 35 and 5. So z1 is 1. So now positive value we obtained. So that is what right side the point is placed. This is the fair diagram. So the question is 40 assumed as x1, x1 is z1. Now we want this is a greater than z1. So this part to be calculated. That is right side to the point of z1. This yellow color shaded one area we have to calculate it. We know it, this line, the vertical line which divides the total area. Always the total probability is 1. So on that, if it divides equally, on that based, this area is 0.5. That of section, this is 0.5. So this from 0 to it goes on, whatever it is, the area is 0.5. But we want the shaded part area. So the 0.5 from which this data we can subtract it. That's what which is written here. So our Z1 we calculated 1 and 0.5 minus 0.3413. This data with the use of the normal table, we can see it here. Yes, already it is marked here. This is 1. This value only we picked and we wrote it. Yeah, the particular place we have written. So the calculations we obtained 0.1587. So we can see it actually the specific which area we are focusing under calculation. Why it is placed? Because of positive. This is the star mark which indicates this completely this domain, the area only we calculated. So the next question is x is less than 20. So the 20 we assumed as x1. It should be converted into z1 using the scale, and we used it. That is particular x1 is 20, mu and sigma which are replaced by as 35 and 5. Finally the output we obtained minus 3. So the minus 3 which is negative. So because of the negative, it is placed on the left to the point of z equal to 0. So it is placed here. So the star which indicates, so we can see it, it is minus 3. That is the reason it moves to z1 left side and the point which is the vertical line which is drawn. The calculation part we can see it, 20, x1, z1, and this is the formula, 0.5 minus area of z1. Here we can see it, the diagram. This is the final diagram. So from here to it moves on, because if it is less than 20, less than z1. So left side of z1, here, this completely this section is 0.5. We needed this shaded part only. So 0.5 and this should be subtracted. We did the formula and z1 we obtained minus 3, and this value how we obtained. So we can see it here, more 3 is there. That seeing this cycle here, the 3, the value should be obtained. it is placed here. So the calculations, and we got it 0.0013. So this is the domain. It is the star indicates we are finding, we evaluated that the result is 0.0013. So the final one is this normal distribution, the problem. X is greater than 50. The similar way, the 50, that is, we named it as x1. When x1 equal to 50, the scale x1 minus mu by sigma, that is, we substituted in the particular place as mu and sigma, we obtained the result plus 3. So if it is plus 3, we know it very well that it should be placed on the right hand side. It is placed, and the vertical line which is drawn from Z1. So we can see it. The star which indicates, that is, the value what we obtained is positive. That's what right hand side is selected. The point is Z1 and vertical line which is drawn. So this is a final diagram of this particular x is greater than 50. That is 50 as x1, x1 as z1, and this is the formula how we obtained it. That is, here z1 is there. This is the shaded area we required. We have to evaluate. So this off section is 0.5, the area. So this goes on infinity. From this unwanted data, we can subtract what is our expected data will come out. So 0.5 minus area of Z1. Z1 we obtained plus 3, and the particular result using the normal distribution table, we can obtain 0.4987. The final result is 0.0013. Yes, the star indicates why it is placed because of the positive, and the movement of the star is the domain of area we evaluated, that is 0.0013. So this is the points in this particular problem we have taken, that is -2, 1, -3, 3. The different points we obtained using this normal distribution table. The points are picked and we substituted in the particular places. So far what we are discussed, the problem mu and sigma both are given. If they are not given, how to go about it, that we are going to discuss. Suppose 10% of the probability for the normal distribution is below 35. Below 35 is 10%. Above 90 is 5%. That's what our given data. Fine. What are the values of mu and sigma? Then this problem comes under normal distribution when mu and sigma which are not given. How to deal? Yeah, we will solve this problem. Mu, it is a symbol of mean. Sigma, it is a symbol of standard deviation. So x is less than 35. That is a condition which is given in the question. Below 35 is 10%. Decimally, we have written 0.1, that is 10 by 100. Next is above 90. What are the conditions which are given first? We can finish our job. 5%. Yes, it is given. Decimal is 0.05. 5 by 100. So when x is less than 35, the 35 we are giving the name x1. So this is the scale, x1 minus mu by sigma. So 35, that is our question, x. Mu and sigma we don't know in this particular problem. So just we are writing z1. The question is, we can write only z1. Why the minus sign should be kept? It's a good question. Why we kept the minus sign? Because of less than symbol. It gives an indication that the point which is going to come, which is going to take that particular place, it is going to be negative left side to the point of z equal to 0 because of this symbol. Yeah, we are naming as equation 1. The next is above 90. That we named it as x2. Then we have to convert it into z2. Yes, that z2 equal to x2 minus mu by sigma. 90 minus mu by sigma, which is equal to z2. The equation is 2. Fine. Now equation 1 is ready. Equation 2 is ready. The first equation, the normal distribution, it's a very, very beautiful concept. When mu and sigma are given, when mu and sigma, they are not given. Very beautiful concept. In this video lecture, each and every line which is explained. Now, this equation 1, just we have written, only the thing is z1 place, the point we have taken 1.28. Suddenly, how is it possible to write what based on assumption we have taken this 1.28? Time being, I'm requesting the students accept it. Just finishing this, we will come back again how we have taken that 1.28. Yes, now 35 minus mu, the sigma we are bringing here. So this minus mu, it crosses, it has become plus mu, that the equation is 3. That is 35 equal to mu minus 1.28 sigma. So we can see it here, the bell-shaped curve. This is the initial stages of getting the fair diagram. X is less than 35, 0.1, we got it. Greater than 90, 0.05. These calculations already we have done it. Now, x1 equal to 35. 35, the name we have given x1, but it is not possible to plot it. Because here, under the normal curve, z points are plotted, but we don't know what is z1. But the z1 is going to come on the left side, assuming we have drawn the vertical line. Next, x2 equal to 90, that is greater than. So, it is going to come. x2 we know, but we don't know what is z2. But it is going to come to occupy the place of right side of z equal to 0. That is what the right side, the vertical line which is drawn. Now, this point, the area which is given, 0.1, this half section, we know it, 0.5. If it is, this is 0.1, this is 0.4. Yes. Next, this is 0.005 given data of the problem. Then this is 0.45. This how we felt because of this vertical line which divides the area equally, 0.5 and 0.5. The total probability is always 1. We don't know what is Z1. We don't know what is Z2. Now, here that can see it, the star indicates 0.1 because of less than symbol. It is placed left side. It is 0.05 because of positive greater than. It goes to right side. So this is the fair diagram. This equation 3, this Only this value I told time being accepted. The explanation I'll give later. The next equation is 90 minus mu by sigma equal to Z2. This is also value time being we will accept it 1.65. So the sigma we are placing to the next side. So 90 minus mu equal to 1.65 sigma. That is equation 4. So the equation 3 and 4 we can solve. So 35 equal to mu minus 1.28 sigma, 90 equal to mu plus 1.65 sigma. So taking the opposite signs, if you cancel, minus 55 equal to minus 2.93 sigma, the sigma is 18.77. So any one of the equations, either 3 or 4, if you substitute, we will be getting the value of mu. Everything is fine, but only the doubt on what based we have taken this 1.28 and this 1.65. Yeah, now we will discuss about it. Before that, yes, what actually the star which indicates, that is 35 x equal to this, how we obtained. These are the points. Once again, we can see it here. The value, that is, here we can say the star. It is going to come there, Z1. We don't know the point. Here, X2, but we can't mark it. But Z2 is going to come in that particular place. So our aim is, the star indicates we have to find what is Z1 and Z2. So any one of the equations we can substitute. Here we have taken the equation 3. That is 35 equal to mu minus 1.28 sigma. We substituted in the particular place 18.77. We obtained the value mu as 59.025. Approximately we can take 59.03. Yes, now I told you that 1.28 and 1.65, the explanation. Yes, now. So we can see it, x is less than 35. This is the data we calculated according to our given condition. Above 90, 0.05. x1 equal to 35, but it is not possible for us to plot in the diagram because only z points satisfying the scale x minus mu by sigma, those points only to be plotted under the normal curve. But we can, the point where, because of the less than 35, the vertical line which is selected on the left side. Fine. This is given, the area which is given 0.1, it is there. How we obtained this 0.4? Because of that we subtracted 0.5. 0.1 which is subtracted from 0.5, we obtain 0.4. So this is the point to be calculated. So compulsory when evaluating the normal distribution table, the scale, that is from 0 to that 0 to be included. So from here to here, this point to be calculated, that with the help of the normal distribution table, that is Z1. The similar way, here X2 is there. Why we selected the right side? Because of above. The point, the area is 0.05. If we subtract from 0.5, we obtain 0.45. Now, from here to here, the point that with the help of the normal distribution table, 0.45 to be searched, what we are getting, the output is Z2. So what is Z1? What is Z2? The answer will come out with the help of normal distribution table. So this is the rough diagram. We can see it the fair diagram. So this is the star which indicates, this is the complete the diagram for this when mu and sigma, when they are not given under this bell-shaped normal curve. So this is a fair diagram. So here 35, that is x1 equal to 35, z1 is going to come. The shaded part of this is, here this is x2, that is 90, we can't plot it. Z2, this area we have to, and for this area to be calculated. This is a fair diagram. So we can see it. This is the point to be calculated. That's what the star indicates. And this is the point for Z2 to be calculated. So 0.4. Here we have to search. Where is 0.4? We can see it here. 3.8, and here we can come. Here you can see it. This one. 0.3997 is there. It is nearer to our 0.4000. That's what here I am drawing a line. Yeah. So now I think so the students are getting satisfaction. 1.28, which is selected. Now the next one is 0.45. Here we have to search this point. You can see it, I am drawing a line. 1.65. 1.6, here you can adding 1.6, 0.05. It's nothing but 1.65. One more doubt also it may occur, that is which will ring in our mind, that why we have to take this is 0.4505. This is also nearer, nothing wrong in it. Which is nearer to 0.4500? That point we have to select. So we are coming to the conclusion of this topic, problems on probability distribution. This is not the video only for watching, teaching and learning. Completely I'm requesting the students just on pen and note, start doing. Definitely the end of the video lecture, complete satisfaction, that learning satisfaction will be got by you people. The first one is the definition of binomial distribution. We discussed it. NC p power x q power n minus x. P and Q, probability of success and probability of failure. X is taking the value from 0 to n, whereas Poisson 0 to infinity. That point to be noted. And Poisson, the Denis Poisson, he derived the formula from binomial distribution, and he presented to us that the formula e power minus lambda into lambda power x by x factorial. Next, normal curve, the bell-shaped normal curve, using when mu and sigma are given, when they are not given, we discussed in detail, taking the problems. The first, this is the problem, 6 dice are thrown 729 times, and the condition getting 5 or 6. The second one, same binomial distribution, that is that workers, they are suffering from disease. That is a condition which is given. 20% are suffering. Randomly 6 workers are selected. The question is greater than or equal to 4. That we discussed under binomial distribution. Then we moved to Poisson, that is the manufacturing, that is a condenses. 1% is defective. The box contains 100. The question is 3 or more. The next we moved to again Poisson, that is the seeds are there. The total seeds 5% are not fit for germination. Each packet 200. Then what is the question which is asked? Here the question is twisted. It is not a direct question, this problem. That is, germination is 90%. They didn't ask the probability of germinating. They asked the probability of not fit for germination. So this is also we discussed. Then we moved to normal distribution. 1000 students are there. Mu and sigma which are given between 25 and 40. Yes, this is the result we obtained. The next one is greater than 40. This is the graphical representation. We have done it. The next, x is less than 20. This is the graphical representation which is done. So the next one is when mu and sigma, we have to find that how to move it. So the given conditions are filled. We found x is less than 35, 0.1, x is greater than 90, 0.05. For this is the result. We obtained the graphical representation. For the graphical representation, what are the background of this, the fair representations to get the initial stages also, which are explained in detail. So this is the rough diagram of this particular problem. This is the fair diagram, and here the points to be plotted, Z1 and Z2, wherever it is there, the star indication also presented. So totally we discussed in very detail about the probability distributions, binomial, Poisson and normal curve up to the satisfaction of students' community. So this is a scale which helped for the normal curves, normal distribution. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.